Okay, so hello, we are here to revise for the end of year exam for Sec 1. So this is chapter 3. Okay, chapter 3 has two parts actually. The first part is about elements, compounds, and mixtures. So I think let's tackle the first part. What are elements, compounds, and mixtures? Now, importantly, you need to know, actually over here, what we are studying is chemical substances, basically chemicals. So a lot of chemicals are around us. Take for example, water is a chemical, carbon dioxide is a chemical, air is also a chemical, right? So all sorts of things around us are chemicals. So we need to find a way to classify them. So one way to classify chemical substances is based on the properties and the particles that it has. So we can classify them into element, compound, and mixture. So a chemical is either an element, compound, or mixture. So now let's delve into each one of the three of them. So the first one is element. So now I'm going to start by drawing the particles in an element, and you will understand why they are elements. So you can see clearly these are elements. I've drawn you the particles in one element, right? Another way to draw elements could be this. Okay, this is another sort of element. So how can you tell from this diagram that these are elements? You can tell that these are elements because they contain only one type of particle. And if you recall today, we said that these particles are atoms. They contain only one type of atom. As you can see from the one type of circle it contains, all of them only contain the white circle, if you like. Okay, so because it contains only one type of atom, it is an element. Okay, but we can go one step further. You can see that the element on the left is different from the element on the right. How can you tell? You can see that the element on the left, the arrangement of the particles is different. The arrangement of the particles on the left tells you that this must be in the gaseous state. So we say that it's a gaseous element. It's gaseous, it's a gas, because the particles are spaced far apart in an irregular manner. Okay, so that's how you tell the one on the left is gaseous. On the other hand, the one on the right, you can see that it's a solid element. Okay, so just based on the particle arrangement, not only can we tell it's an element because there's one type of circle, one type of atom, we can also tell the state of matter, gaseous or solid. All right. Now, elements can be found in the periodic table. So importantly, the list of elements is in the periodic table. Now, the periodic table is given to you in an exam paper. It's usually at the back of the exam paper. So that's where you find all the elements, right? So for instance, you can find hydrogen, oxygen, nitrogen, magnesium, sodium, lithium, and so on. So basically, the list of elements is in the periodic table. Okay, so if you can find it in the periodic table, it's an element. So iron is an element. Copper is an element. Okay, now elements can be divided into two types as well. So in the periodic table, there are two types of elements. There is metals and non-metals. So you will need to know where are the metals and non-metals in a periodic table. So you can find metals on the left side of the periodic table. So on the left-hand side will be metals, whereas on the right-hand side will be non-metals. Okay? So for instance, sodium, calcium, aluminium, these are metals because they are found towards the left side of the periodic table. Okay, so that is the concept of elements. So up to this stage, based on the particles, I can tell what is an element. I can also tell metals apart from non-metals based on the position in the periodic table. Okay, so now I shall move on to compounds. So what are compounds? So I think it's better understood again when we draw the particles. Okay, so this is a compound. How do I know that this is a compound? Firstly, I can clearly see two types of circles, right? There's the shaded one and there's the white colored one. So this tells me that there are two types of atoms. Two types of atoms mean two elements and they are joined together. When we join them together, what we actually mean is two or more elements chemically combined together. Okay, so when we join them together, there's a reason for this. We are actually saying that they are chemically combined. And they are not just chemically combined in any random manner. You can clearly see that there is actually two dark circles for one white circle. So they are chemically combined together in a fixed ratio. So in this case, two dark circles with one white circle. Okay? So over here, this particular compound, it could very well be H2O, water, right? So you can see that water is a compound because it contains hydrogen and oxygen, right? It contains two elements, hydrogen, H, oxygen, O. And they are combined together in a 2:1 ratio, two hydrogen to one oxygen. That's why we say that it has a fixed ratio, okay? Now, besides that, because it's chemically combined together, chemical combined together means it is formed by a chemical reaction. So for example, to form water, what we do is that we burn the hydrogen in oxygen. So we burn hydrogen in oxygen. They burn. Burning is a chemical reaction. Okay? And because it's a chemical reaction, you will release a lot of either heat or light energy. So you release either a lot of heat energy or a lot of light energy when compounds are formed. Okay? So for instance, when you burn hydrogen in oxygen, that process releases a lot of heat as well as light in the case of burning. Okay? So that's a characteristics of compounds. Okay? Now let's number the characteristics to remind ourselves. The first characteristic is that it's chemically combined together in a fixed ratio. The second characteristic is that it's formed by a chemical reaction, therefore a lot of heat or light energy is released. Okay? Now, finally, the third characteristic, because it's chemically joined or chemically combined, these are chemical reactions that formed it. They form these chemical bonds. It's very hard to break down the compound. You cannot separate the compound by physical methods. So what is the meaning of physical methods? So physical methods are things like filtration. I cannot just separate the hydrogen and oxygen in water through filtration. Doesn't work. Okay, chromatography. Okay, I cannot just do chromatography and expect the hydrogen and oxygen to come apart. They won't come apart because the hydrogen and oxygen have already been chemically combined together to form water. So I cannot use physical methods like filtration, chromatography to separate them. Okay, there's no way to separate or break down the water just by these physical methods. Okay, and that really sums up what you need to know in terms of drawing of compounds. You need to know the 3 characteristics of compounds listed there. So now we move on to mixtures. So we have done elements, we have done compounds. So these are quite clear-cut in terms of the arrangement of the particles and the types of particles that they contain. Now, if we were to draw mixtures, they might look something like this. Okay, that's one example of a mixture. Another example of a mixture could also look something like this. Okay, so I've drawn 2 different types of mixtures for you. However, they are still mixtures. Now, importantly, if we zoom into these 2 different types of mixtures, which are all mixtures, you need to know how to analyze them. And the way to analyze them now is to put a box around every single type of combination that you see. So in the first box, you see that, oh, I have 2 white circles combined together. I also have 2 dark circles combined together. I'm sure you will agree with me. Each one of these is an element. Each box here is an element. Of course, there's one element, there's another element. And hence, in the box on the left, we will call this a mixture of 2 elements. So the key thing is it contains 2 elements, but are these 2 elements combined together? I think just now we said, if they're combined together, you should see the circles join together. So is the white circle joined to the dark circle? And the answer, of course, in this picture, the white circle is not joined to the dark circle. So these 2 elements are actually not chemically combined together. Okay? And hence, that's the first difference between compounds and mixtures. The mixtures contain 2 or more substances that are not chemically combined together. And because they are not chemically combined together, they do not have a fixed ratio, like just now, right? They don't have a ratio of 2 hydrogen to 1 oxygen. There's no fixed ratio. Another word for fixed ratio, fixed proportion, or fixed composition. Okay, this one is a commonly used phrase. We actually use these phrases interchangeably: fixed ratio, fixed proportion, fixed composition. So mixtures do not have a fixed ratio of the substances that they contain. So like, for example, in the mixture of the 2 elements that you saw, maybe I can have more of the darker element than the white element. Okay? The ratio need not be fixed. So on the left, we see a mixture of 2 elements. The 2 elements are not chemically combined together because they're not joined. Then we move to the right-hand side, also mixture. But this time around, we box up. This one is element because it contains 2 white circles only. However, another combination that we saw is that now we have this combination whereby 2 dark circles is joined to 1 white circle. When they are joined, it means it's chemically combined. That means this box where 2 dark circles join to the white circle, this is compound. So what would you call the box on the right-hand side? This is a mixture of 1 element and 1 compound. Because I know that there's an element, I also know that there's a compound inside this mixture. Is the element and compound chemically combined together? So you look, are the two boxes, the element and the compound, chemically combined? As shown, the element and the compound, they are not joined. They are not joined together means they are not chemically combined together. Okay, so that is the first difference. Mixtures, they are not chemically combined together. They do not have a fixed ratio, proportion, or composition of substances. Okay, so now that's the first difference between mixture and compound. The fact that mixtures do not have a fixed ratio, proportion, or composition of substances. Now, the second main difference is a result of them not being chemically combined. In compounds, they are chemically combined together. The elements are chemically combined together. As a result, it means that compounds are formed by chemical reaction. So for instance, some mixtures are solutions. So I dissolve sugar in water. So the sugar solution is a mixture. To form the sugar solution, actually, I don't release a lot of heat, right? You dissolve sugar in water, it doesn't release heat a lot. Okay? And finally, because they are not chemically combined together, they can be separated easily by physical methods. So again, what are the physical methods that we have learned? The physical methods that we have learned are things like filtration, chromatography, right? So you have learned filtration, chromatography. Those are examples of physical methods. Okay? That's why in the next chapter, you all actually learn all the different methods for separating mixtures, filtration, chromatography, and so on. Okay? So these are the key differences between compounds and mixtures. Okay, so now that we have learned about elements, compounds, and mixtures, now let's zoom out. So let's remind ourselves, okay? Elements, compounds, and mixtures are basically the ways that we classify chemical substances around us. Okay, so we can clearly see that they look very different in terms of their particle arrangements. So you must be familiar with how the particles are arranged. If I give you a picture, a diagram of the particles inside the substance, you must be able to tell me if it's element, compound, or mixture. Okay, and for mixtures, you should even go deeper. Tell me it's a mixture of what? Is it a mixture of two elements? Is it a mixture of elements and compounds? Okay, now, so we come to this idea that, hey, so elements and compounds, basically they contain only one substance, right? So for example, water, all of it is H2O. It's the same type of molecule. It's the same substance. So basically, elements and compounds are pure. Whereas mixtures are impure. Okay, mixtures are impure. Only mixtures are impure. So how can you differentiate between pure and impure substances in the lab? Now, to determine the purity of a substance, we look at the melting and boiling point. For pure substances, they will have fixed melting and boiling points. So if you think about the compound H2O, water melts at 0 degrees Celsius, it boils at 100 degrees Celsius, right? So it's very clear cut. The melting point of water is a fixed number. It will only melt at this temperature, not at another temperature. So as it's melting, the water remains at 0 degrees. It will not go to 1 degrees while it's melting. Okay? Whereas the opposite happens for impure mixtures. So mixtures are impure, therefore they do not have a fixed melting and boiling point. Now, what does it mean by don't have a fixed melting and boiling point? It means that it melts and boils over a range of temperatures. Okay, so for instance, if you have a mixture of salt and water, it could very well boil from 98 degrees to like 104 degrees. So the idea is if it's impure, if there's some impurities in that mixture, then that mixture is going to melt and boil over like a range of temperatures. So for instance, they tell you the boiling point is 98 to 104 degrees. If it's a range like that, you know that it's impure. It's a mixture. All right. Let's move on. So now let's move on to the next concept, which is about solutions and suspensions. So we look deeper at mixtures now. So out of elements, compounds, mixtures, I separate my mixtures further. So there are two types of mixtures, solution and suspension. So what is the difference? Maybe let's give an example. Solution is like sugar dissolved in water. All right. Whereas suspension is like sand in water. So what is the difference? The main difference is about dissolving. If the substance can dissolve, that means it forms a solution. So the idea behind this is solutions contain dissolved solids. That means there should be no insoluble solids at the bottom. You should see no solid left sunk to the bottom. Whereas for a suspension, there will still be insoluble solid that sink to the bottom. The next important difference is for a solution, okay, it allows all light to pass through. It allows light to pass through it. That means it's transparent. Okay, and that's a solution. Whereas for a suspension, it does not allow light to pass through. Okay, and the final important difference, for a solution, because everything is dissolved, you cannot separate it using filtration. There's no solid to filter out. The solid is dissolved in water. So like sugar dissolved in water. You cannot filter the sugar because the sugar is already dissolved. You need to use another method to get the sugar back. Whereas for suspension, like sand in water, you can separate by filtration. Okay, so these are the broad differences between solutions and suspensions. Okay, so we have gone from element compound mixture. Now we delve deep into mixtures. We know there are two types of mixtures, solutions and suspensions. Now the last thing we're going to delve deeper into is solutions. So solutions are all around us, right? So take for example, you dissolve sugar in water. So the sugar is the solid which you dissolve, right? So this is called the solute. Water is the liquid that you add to that you pour to dissolve the solute. So water is the solvent. Now, is water the only kind of solvent? The answer is no. There are other types of solvents as well. Take for example, there is water. Sometimes you use alcohol. More commonly is ethanol. Ethanol is a type of alcohol. All right. Sometimes you even use oil as the solvent. So oil can dissolve certain things as well. Okay, so there are many types of solvents. Of course, changing the solvent would mean that I change the solubility. And this gives rise to the two concepts that we're going to go through. Solubility as well as rate of dissolving, which we actually started together in class today as part of the revision. So if you recall from the lesson today, I mentioned about solubility. Solubility is actually the maximum amount of solute that can dissolve in a fixed volume of solvent. That means if I take 100 cm cube of water, how much sugar can dissolve in 100 cm cube of water? That tells me the solubility of sugar. Okay, so this is the definition for solubility. It's the maximum amount of solute which can dissolve in a fixed volume of solvent. And there are three factors which affect the solubility of a substance. Now, the solubility is affected, of course, by the type or the nature of the solute. So it depends on what you are dissolving. Is it sugar? Is it salt? Or is it something else? All right, so the solute matters. Different solutes will have different solubilities. The solvent also makes a difference. Whether you have used water, alcohol, or oil will make a difference to the solubility. Sugar, for example, sugar dissolves in water, but sugar doesn't dissolve in oil. Okay, so the solubility of sugar in water is higher than the solubility of sugar in oil. And finally, temperature. Now, generally speaking, but not always, the higher the temperature, the higher the solubility, generally, but not always. Okay? So these are the three factors which affect solubility. So you take note, solubility is about amount, how much, okay, how much can dissolve. There's nothing here about time. It's not about how fast, it's about how much, that solubility. So now we move on to the last concept, which is rate of dissolving. Rate of dissolving is about the speed, how fast, how quickly, how fast a fixed amount of solute can dissolve in a fixed volume of solvent. So the idea here now is about speed, time. I'm looking at how long it takes to dissolve something, okay? Now this is also affected by three factors, but the three factors are not the same. Okay, so the first factor that affects rate of dissolving is the surface area of the solute. Okay, and under this point, you need to know if it's powdered or fine crystals, it's faster. So for instance, if you use powdered sugar or fine crystals of sugar, it dissolves faster because the surface area that's exposed is larger. So that's the first factor affecting the rate of dissolving, surface area of solute. The second factor which affects the rate of dissolving is, of course, the rate of stirring. Okay, so you can call it stirring or stirring rate. The more quickly you stir, the faster the solute will dissolve. Okay, because what you do with stirring is that you're actually causing the particles to collide with each other more frequently. As a result, the particles of sugar collide with the particles of water more frequently and they dissolve faster into each other. And finally, the last factor, which is also a factor affecting solubility, is temperature. And today in class, we explained higher temperature, faster rate of dissolving. All right. So higher temperature means the particles have more energy. So when the particles have more kinetic energy, they also move faster. All right. And that's why there's a faster rate of dissolving. Okay. So these are the three factors which affect rate of dissolving. You can see that it's quite different from the factors affecting solubility. So these are two different concepts altogether. So I advise you to learn them separately, but under each concept, you learn the factors which affect that particular property. Okay. And with that, actually, we have come to the end of chapter 3's revision. Okay. And that's where we stop the recording now. Okay. Thank you.